So when we solve three equations with three unknowns, it's going to be very similar to how we did two equations with two unknowns. So first off, we need to remember that in order to solve any system of equations, the number of equations and the numbers of variables have to be the same. So this is very important. If you have more variables than equations, you're not going to be able to get down to one specific answer. One thing I'm also going to point out is that the steps on how to solve these are listed out on page 144 of your textbook. So I'm not going to go through and list the steps individually on here, but I highly recommend you use those and follow them as you're doing your own. And if you want to write them in your notes, it's a good idea to do so. I will try to color code these notes as I go. So first things first, we want to figure out, using two equations, how we can get one of our variables to add to 0 so that we can basically get rid of them. So I'm going to use these second two equations. When we add them together, we get 4x minus y equals 2. So notice we got rid of our z. And notice we got rid of z. So what we want to do is pick two different equations instead of the second and third, and also get rid of z. So one way to do that is multiply the second one if we multiply this by -2, what we'll end up with is -2x minus 4y minus 4z equals -22. And then we can use that with the first equation and get another equation this way. So our x's will disappear. We'll have -3y equals -6. And notice now we already have our y value we can solve to be 2. And so now what we can do is plug this back into this equation. So now we have a value for y and a value for x. We can use both of these values and pick any of our beginning equations to figure out what z is. So I'm just going to go with the second equation. It doesn't matter, so I'll just rewrite it. Now we know that x was 1. We know that y is 2. So the ordered triplet we have, and it's a triplet because we've got 3, is 1, 2, 3. It goes x, y, z. Now, we always want to make sure that we check our answer. So going back to our original equations and trying all of them. Alright, so we're going to check it with the first one. We had 1 for x, 2 for y, and 3 for z. So our first equation works. works in the second. And works in the third, so we are good. Now the second one, same thing. We want to start by picking two equations in which we can eliminate one variable. So I'm going to start by picking the second and the third ones again. And it doesn't matter which variable you decide to get rid of. So we have a minus c equals 3. Now we've got to pick two more equations. And since we got rid of b in the first one, we've got to get rid of b in the second one. So what I'm going to do is I've got the first one. And I'm going to go with the second one. Notice our c's would cancel out, but since we got rid of b here, we have to get rid of b here. So what I'm going to do is multiply the second equation by 3. So this first one stays the same. And the second one is going to become 9a minus 3b minus 6c equals negative 6. So now notice we have two equations, this one and this one, that neither one have a b. So what we're going to do is put those two equations together. Just like we have been in the previous sections of this chapter. So it doesn't matter which one we decide we want to get rid of. I'm going to go ahead and just multiply this top one by negative 4. And now that we have a value for a, we can plug that back in to either the red or blue we have up here. So I'm just going to go back to the a minus c equals 3 and plug in my negative 2. So now we have an a value and a c value. And then go back to one of the originals and plug in the a and the c to get our b. So we get negative 2, 6, negative 5 for our ordered triplet. Remember, we want to check our solution. So it works. All right, so now for this one, the very first thing we want to do is set up our variables. So I'm just going to do A is the price per pound for apples. B is the price per pound for berries. And then C is the price per pound for cherries. Make sure when you're deciding your variables, you actually come up with variables that make sense in your situation so you can remember what each one stood for. If you just pick X, Y, and Z, it's going to be hard to remember which ones were which. So now we want to come up with our equations. So the first one, we had $34 for 2 pounds of apples, 1 pound of berry, and 4 pounds of cherries. 35 for 3 pounds of apples, 2 pounds of berries, 2 pounds of cherries, and 49 for 5 pounds of apples, 3 pounds of berries, and 2 pounds of cherries. So once again, start by figuring out which variable you want to eliminate. So I'm just going to go with the bottom two equations. Notice no variable is going to divide out right away, but we can multiply this first one by -1. And now we want to pick two different ones. And we got rid of C, so we want to get rid of C again. We can multiply the second one by -2. So now our two equations that just have an A and a B. I'm going to go ahead and multiply this top one by 3. So now we can plug this back into either of the equations that only had an A or a B. So I'm just going to go back to 2A plus B equals 14. And we now know that A is 3. We know A is 3, B is 8. Go back to one of the originals to figure out C. So now in this case, we don't necessarily want to write it as an ordered pair, because since it was an actual contextual situation, we want to write what it actually means. So we know that apples are $3 a pound. berries are $8 a pound, and cherries are $5 a pound. And then once again, we need to check our answers. And there you go.